All right, so again, starting our coding app, we'll just kind of skip through that. So first off, we're just going to look at a quick checklist of the things that we're going to need for our app. There's a lot of stuff that we need for this app. Just looking at our system analysis, this is the second page of that engineering portfolio, right? This page here. Again, if you haven't been filling this out, it's going to make this a lot harder. If you have, as you go, again, just quickly like putting things in and typing things out. Are we going to get the mass of the jumper? We're going to measure it. Or we're going to ask the jumper. But we're probably just going to measure it because we don't always trust the jumper. So on and so forth. So from our system analysis, these are all the things that it talks about. It talks about knowing the mass of the jumper. It talks about knowing the starting height, how much added string, unstretched bungee, spring constant, distance the bungee stretches, height of the jumper, buffer, ending height, no-go zone. Right? Those are all the different things that are on our system analysis. Some things that aren't really on our system analysis, I mean, they kind of are, but not really. Starting gravitational energy. Right? That's this stuff over here where we talk about that starting energy. So it's sort of on there. Total energy. Remember that the total energy needs to be constant, which means that once we know how much starting gravitational energy there is, that is the total energy, and that should stay constant the whole jump. Ending gravitational energy, again, on the left side of the system analysis, sort of. And then ending elastic energy. So again, these ones are, again, a little bit harder, but we'll kind of take a look at how to figure those things out. All about conservation of energy, all about those bar charts on the left-hand side that you guys should have filled out. So the next thing we're going to do, again, to try and think about how we're going to put this into our app, is we're going to sort this gigantic list. We're going to think about the things that we're going to need as inputs. And we're going to think about the things that we're going to need to calculate. So again, looking through each of these, we can think about how we're going to get the information. Are we going to get the information by calculating something? Or are we going to get the information by measuring or asking about something? So pause here, try to sort through this list as best you can, and then we'll kind of go through this together real quick. All right, so let's go ahead and see. And again, if you guys got some of these things in the wrong categories or whatever, no big deal. The inputs, these are experiments or values that we collect ahead of time. So the mass of the jumper, again, we can measure that as they get to the jump itself, right? Quick little measurement of their mass. The starting height, they're going to tell us, right? Do they want to jump from the highest spot or the next spot? Length of the unstretched bungee. Again, this shouldn't change from jump to jump. So you guys should be able to measure this ahead of time and not worry about it. The spring constant. That's the lab that we did today, or day 6, depending on when you're watching this video. And again, that does not change from jump to jump. Your value might be different than somebody else's value, but your value will not change. The height of the jumper. Again, you'd have some way of measuring the height of these jumpers as they come up. For us, measuring the height of our water bottles is pretty easy. The buffer and no-go zone, these are based on the poster, right? This poster that we're going to be using to try and figure out where we're trying to jump to. So that poster is going to be what we measure to figure out the buffer and no-go zone. And then all the other things are going to be calculations, which is actually good because once we set it up, the computer is going to do all the calculating for us. Calculating starting gravitational, calculating the total energy, calculating the gravitational at the end, calculating the elastic energy at the end, calculating how much string needs to be added, calculating the bungee stretch, and calculating the ending height. All of these things have a formula for them. And so we're going to go ahead and look at those formulas, but they're all based on either the inputs or other calculations. Now, when you guys are designing your app, you're going to be thinking about these inputs, you're going to be thinking about these calculations, and thinking about what makes the most sense for the design layout of your app. So we know all the parts, we know what's an input, we know what's a calculation. Some things to think about are, what are the things that the operator, right? The jump operator, you, when you are dropping your water bottle, what are you going to be changing the most, right? Are those easily accessible? Are those easy to find and easy to change? And what is the output? What is the overall output that you're going to want? Make sure those things are super visible, super easy to get to. All the other stuff should be hidden, right? We want to make it as user-friendly as possible. Again, these calculations should come from our system analysis page. We talked about the starting gravitational energy being the mass of the jumper times the starting height times gravity, or 9.8. We talked about the total energy has to equal that starting gravitational, right? Because that's all the energy that you start with. And that energy has to be conserved. That is the total energy. That's the total starting energy. That's the total energy at the end. That never changes. The ending gravitational, mass times ending height times gravity. Again, based on where we want them to end, where we want them to stop. Ending elastic energy we get by subtracting, right? We know that the total energy at the end is composed of ending gravitational and ending elastic. So if we subtract the ending gravitational from the total, we get the ending elastic energy. We know how much energy is stored in the elastic band. To find the distance that the bungee stretches, right? This is just a rearranging of that equation that we were working on the other day, where we saw that elastic energy equals 1/2 kx squared. This time we want the x by itself. So we rearrange things and we get that the ending elastic energy times 2 divided by the spring constant. And if you raise all of that to the 0.5 power, which is the same thing as taking the square root, you'll get the distance the bungee stretches. Again, you don't need to know how to get there, right? You're just going to need to use that equation. The ending height, again, we're going to measure the no-go zone. We're going to measure the buffer. And when you add those together, you get your ending height, where you want them to end. Added string. This is the final calculation. This is the most important part. This is the part that the operator wants. They want to know, how much string do I add to the bungee so that the person can have a fun bungee jump? We know how much the bungee is going to stretch. We just need to know how much string to get them to just the right location. And the way that we're going to do this, starting height, where we're starting the jump. We're going to subtract off some things. Subtract off the ending height. Subtract off the height of the jumper. Subtract off the length of the unstretched bungee. Subtract off the distance that the bungee stretches. And what's left is how much string we need to add so that they're in just the right location at just the right time. Again, pause the video here so that you guys can do the coding of your app, right? For the spot that says starting gravitational energy in your equation, right? You're going to type in equals. You're going to click on the square that has the mass of the jumper. You're going to hit Shift 8 to get the multiplication asterisk. You're going to click on the starting height. You're going to do Shift 8 again to get another multiplication asterisk. Multiply it by gravity, which is 9.8. The important part about selecting the cells and not just putting a number like 5 for the mass of the jumper is that the next jumper might not have a mass of 5. And you want to make sure that this value changes according to the mass of the jumper and the starting height. So it's important that it is able to change as those variables change. So again, filling out these equations in your app. And your app starts off blank, 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 blank. I don't even have it up right now. Next, we're going to look at some mock data so that you can test to make sure that your app is in fact calculating things correctly. So again, pause here if you need to finish up those formulas. All right, mock data app test number 1. So the only numbers that you should change are going to be these inputs, right? Go ahead and put these inputs in. And when you're putting them in, don't put the letters. Don't put the units, because then your program won't know how to calculate things. Only put the numbers. So put in a mass of 0.4 for the jumper, a starting height of 4.5 meters, length of the unstretched bungee as 0.35, spring constant of 3, jumper height of 0.3, buffer of 0.1, no-go zone of 0.2, and of course gravity of 9.8. Again, that value can be hard-coded in to your app because gravity is not going to change, right? The only way that would change is if we were on another planet or moon or something like that. So that can be hard-coded in. And what you should get for your output is 0.24 meters. So if all of the coding is done correctly, this is the output that you should get. And if it's not the output that you get, we're going to try and troubleshoot that real quick. So with the numbers that we had, right, these are the output calculations that should show up. So if one of these isn't showing up, that tells you where the mistake is, right? If your starting gravitational energy is something other than 17.6, then your app is not multiplying things correctly to give you the correct starting energy. Remember, that was mgh. So what it should be is our mass times g, or 9.8, times our starting height. So if it multiplies those three things together, that's the value that it should get. And if yours is getting something other than that, again, check the formula, check the input, make sure that your values are calculating correctly. But what you should be getting is 17.6 or 17.64, but it should probably round that off for you. Same thing with all the rest of these. Again, if you're getting something other than these values, that's where your mistake is. Go ahead and fix that. And then hopefully your added string output is done correctly. If you think that everything is working, right? If you think that everything is great, again, you should be able to try some more mock data and double check, right? Again, the only thing you should change are the green values. If you have to change things in the red, you're doing it wrong. Those should automatically update and calculate for you. So here's a new massive jumper, new starting height, all of these values. Make sure that you guys are changing all of those inputs. Again, gravity did not change. I think the buffer and the no-go zone didn't change either. But make sure that you're updating all those values and check to see what the added string needs to be. And again, you should get 1.62 for your output. Again, if something is still wrong, right, then you didn't fix it in the last round. And you need to make sure that you guys fix that so that it works no matter which green inputs you give. And you should go back to mock data 1 to make sure to double check. Keep going back and forth between these until you only have to put in green numbers to get the output that you're desiring. Here's to help troubleshoot. Again, double check the calculations. If these are the things are not showing up, then something is going wrong. If you are really struggling with this app stuff, if you need lots of help with it, the next slide will kind of walk you through how to do that. All right, so again, this video is going to walk you through how to do that stuff so that you guys can check and make sure that you are understanding where all these things come from. Again, it's from the system analysis, just like we had talked about, but he'll actually walk through how to put in those codes. Again, this is not the most user-friendly layout. This is not an A assignment, but it'll get you a passing grade, right? And so if this is something that you need, make sure that you are, in fact, using it. And he'll walk you through how to put in the codes for all the different things and some mock data as well. If you still get stuck, again, let me know, check with a friend, but make sure that you guys are getting the help that you need to be successful. All right, best of luck.